Hey everyone, my name is Youstina and this is Ryan, and today we will be identifying minerals and exploring their different properties. The purpose of this demonstration is to explore the classification of minerals according to several physical properties. Prior to this lesson, students could be introduced to the layers of the earth, where they will look at rocks and minerals found in the crust of the earth. They can then take a deep dive into what rocks and minerals are, where they are found, and how we use them. Once students have an understanding of the different types of rocks, they will then come to realize that minerals make up rocks. And through this demonstration, we'll be looking at color, luster, hardness, and magnetism through the lens of different testing methods. This demonstration is suitable for grade 4 students and will look at specific expectations 2.1 and 2.2 in the Ontario curriculum. Students will be expected to use scratch and streak test materials for the purposes for which they're intended, and understand that when working outdoors, they need to leave the site as it was found. To conduct this demonstration, you need a mineral kit or mineral specimen. You have a lot of mineral options to choose from. Our demonstration focused on tail, feldspar, magnetite, serpentine, and biotite mica. You will also need a streak plate to test for the color of the mineral in its powdered form, a penny or a washer for the scratch test to test for hardness, which is a measure of how well a mineral resists scratching, a magnet for magnetism, and finally the classification table. To engage students, ask them what they see. Ask them where they would find minerals at home, at school, or around them. They would probably start describing the colors of the minerals. Color and luster are the first things someone notices when they view a mineral, yet they're not the best properties to be used in the identification process. Because some minerals come in many different colors, we would need to use additional properties to identify them. Luster is the way a mineral's surface reflects light, so we can use a lot of words to describe it as well. You can demonstrate this activity to the whole class, or they can work in teams. Let your students carefully observe the color and the luster of each mineral. You can give them a color wheel for reference or a vocabulary list to better describe the luster property. So feldspar is pink and greasy, whereas biotite mica is dark and pearly. They could describe magnetite as black metallic, talc is clear and greasy, and serpentine is green and greasy as well. After taking notes of their observations, their table should look similar to this. Another method used to identify minerals is called streak, which is the color of the powder left behind when a mineral is rubbed against a rough white tile or a streak plate. A mineral will have the same streak no matter what color the mineral is. All you have to do for the streak test is to rub the mineral specimen against the streak plate. Let the students then observe the line left on the plate. They would then note their observation using words such as white dark or black streak. Hardness can be measured through a scratch test. It is measured using Mohs scale, which runs from 1 to 10. Any mineral higher on the scale can scratch a mineral lower on the scale. To explore further, let the students predict how well each mineral will resist scratching. This can be done by rating the minerals on Mohs scale using a number between 1 and 10. Older students can also explain the reason behind their rating. After the demonstration, let the students compare their predictions with the correct answer. Using the washer or the loonie, scratch the minerals until they leave a scratch mark. Magnetite has a score of 6 on the scale, whereas talc has a score of 1. And serpentine has a score of 4. At this point, this is what their table should look like. For the magnetic test, we see that feldspar and biotite mica don't have a magnetic pole. On the other hand, magnetite is naturally magnetic. We can see this lump of magnetite attracting the magnet. Finally, talc and serpentine are not magnetic. This lesson can further be extended and set in the context of social studies, where students can explore the impact of humanity and nature on Earth and will come to realize that Earth is a dynamic and an ever-changing planet. Are you ready to rock?